An interstellar object named Oumuamua was detected in October 2017. Its elongated shape seemed to defy the laws of celestial mechanics. Initial data recorded an anomalous acceleration. This acceleration did not correspond to any known gravitational explanation. Yet, a line in the official reports remains blank. Why does this acceleration fail to appear in established stellar motion models? This detail changes the entire understanding of space. The Pan-STARRS report from 2017 established the first measurements of Oumuamua's trajectory. The data indicated an acceleration that could not be attributed solely to stellar pressure or known gravitational interactions. A second layer of anomaly appeared with subsequent physical analyses. An article published in Nature in 2023 examined the hydrogen degassing of the object. The results suggested degassing inconsistent with standard stellar models. Researchers found a physical signature that did not match what is expected of an ordinary interstellar body. NASA and JPL archives detail the protocols for detecting trans-Neptunian objects. But how were these protocols adjusted when faced with data that fell outside the framework of Newtonian physics? The researchers who accessed these files faced data that blurred the line between observed physics and theoretical physics. But who accessed this initial data, and how was it filtered? The accumulation of objects displaying abnormal characteristics forces a re-evaluation of detection protocols. Oumuamua posed a question: is it a natural body, or something else? The imminent arrival of 3I/Atlas in July 2025 strengthens this inquiry. Official NASA models tend to classify these events as measurement errors or unexplained astrophysical phenomena. However, statements from Avi Loeb, a professor at Harvard, introduced an alternative hypothesis. He suggests that these anomalies might indicate a non-conventional origin. The archives show that scientists had to choose between adherence to established models and accepting data that suggested a different physics. Researchers explored hypotheses where objects interact with spacetime in unexplained ways. But if the laws of physics are incomplete, what do these intruders truly represent? The contradiction lies between the dominant scientific doctrine and the observed data. The official position of NASA and JPL classifies the anomalies as measurement errors. Yet, recent analyses, such as those in Nature in 2023, highlight H2 degassings inconsistent with stellar models. What was never explained is why official protocols did not immediately revise their models in response to these anomalies. The question remains: are the observed data incomplete, or are the physical models fundamentally flawed? If the observed data is not merely a measurement error, but a signature of a physics yet to be understood, then are current detection protocols designed to filter a larger reality? The archive suggests that the boundaries of what is considered natural are constantly redefined by observation. What remains unexplained is the nature of the interactions that allow such an object to traverse space and leave a physical trace. Researchers explored scenarios where spacetime itself acts as a variable. This exploration leads to a question far greater than the initial anomaly: if the laws of physics are malleable, what did government agencies choose to withhold from the record? The 2017 report details a trajectory deviation of 1.6%. This variance cannot be reconciled with gravity alone. The archives indicate that this deviation was marked by black bars during internal NASA revisions. This detail, recorded in the JPL logbooks, was never released to the public. Oumuamua is officially classified as an interstellar body. But if the object is merely a manifestation of a greater system, what is concealed within the margins of these declassified reports? And if the anomalies we observe are not errors, but signals from a technology humanity is not yet prepared to recognize? This program is officially closed. What replaced it is the next episode.